Good day, grade 10 students. Today what we're learning about is light and the electromagnetic spectrum. So this is a new unit for us, and we're going to learn today that light is actually associated with energy. We're going to learn that light is a wave, and the length of the wave matters. And light is part of something bigger known as the electromagnetic spectrum. So a wave is a disturbance that transfers energy from one point to another without transferring matter. That means, like, something is not moving across the surface of the wave. The water is actually just moving up and down. And this movement up and down is actually energy. In order for us to understand this energy, we have to understand the properties of waves. Now, the most important property that we're dealing with is something known as wavelength. Now, wavelength is the distance between the tops of the waves. It also is the distance between the troughs of the waves. Troughs are the bottom part. So you can have crests on the top, which is the top part of the wave, and you can have troughs on the bottom. Now the amplitude is known as the height of the wave, also the length that it goes down. So we have this concept called wavelength. Wavelength is the distance between the tops of the waves, right there and there. So that's the distance. That's known as wavelength right there, that distance. Now we also have another term known as frequency. And as wavelength gets shorter, our frequency increases. That means we can fit more waves into the same section. As our wavelength gets longer, that means that we have a lower frequency. So let's go through that again. As we decrease the wavelength, we have a higher frequency, more waves. As we have a longer wavelength, we have a lower frequency, means less waves. Now light is what we see, and we know light is made up of a wave, but guess what? We only can see some of the colors of light. In fact, a lot of animals can actually see a lot of different colors of light that we can't see. We can only see light that has a certain wavelength. As the wavelength gets longer, we can't see it anymore. And so as it gets longer, it's in this direction, we actually have other forms of light: infrared, microwave, and radio. And as visible light, the light that we see, gets shorter, we actually have light that we can't see either, like ultraviolet light, X-rays, and even radiation known as gamma radiation. So the electromagnetic spectrum is basically saying that light is a form of energy, and we only can see a little part. So we are surrounded by millions and billions and countless amounts of invisible light-like waves that we can't even see. Together, all these different light waves or wavelengths are known as electromagnetic radiation. So radio waves are actually very, very long waves, and they have very little energy, but we can use them for things like your cell phone, or we can use them like TV or satellite communications, or even MRIs. And this is great because it's very useful in our society to have this low energy wavelength. It doesn't cause cancer or anything like that. It's very long wavelengths, but we can use it to transfer information. Microwaves are actually a little bit shorter wavelength than radio waves, but they're useful to us as well, and they have more energy, and they have enough energy to actually make water vibrate. And when water vibrates, it heats up our food. So you can use microwaves to heat up water that's in our food. So if you put ice in a microwave, if there's no water on it, if it's pure ice, it actually won't heat up at all. If you have a piece of frozen lasagna or frozen pizza, you put it in the microwave, you need to actually add a little bit of water to it before it will heat up. Infrared waves are actually even shorter still, and we can't see these, but they're useful as well. And certain animals can see these, like mosquitoes, for example. And anything that produces heat actually produces infrared radiation or light. And mosquitoes can actually see this. And if we have motion sensors or night vision goggles, we can see them as well. And so they actually give heat off as well. Ultraviolet rays are actually really, ultra means very, and violet means purple. And they actually have very, very short wavelengths, and you can actually burn your skin from them. So this is actually shorter than visible light. So because it's shorter than visible light, it has more energy than visible light. So visible light has a certain wavelength, and ultraviolet light has even shorter wavelengths. And because it has shorter wavelengths, that means it has more energy, and that's why you can get burned by UV, ultraviolet radiation. It can damage your DNA and even cause cancer. Now, X-rays are even shorter than ultraviolet light, and they're crazy because guess what? They actually go right through your flesh but not your bones. They have enough energy to go right through your flesh but not your bones. And that's why when you expose a picture to X-rays, and you would actually be able to see through bone. Gamma radiation is even sort of the shortest light that we know of, and you know what's special about it is it has so much energy that it will actually destroy things. So we use gamma radiation to kill cancer cells, for example. So if you were to get cancer, you might get gamma ray treatment, and it will actually target the cancer cells that you want to kill. It's light with a very, very short wavelength and a lot of energy. So as we mentioned earlier, the wave model of light means that light is actually made up of waves, and we know that white light is actually made up of all the colors. Now it turns out that each color of light actually has a different amount of energy. For example, red light has a very large wavelength, so it actually has, this is a long wavelength from here to here, so it has less energy than when we look at purple light, which has a very short wavelength. And because it has a short wavelength, it has more energy. So purple light and blue light actually has more energy. So if you had a red laser as opposed to a blue laser, the blue laser will give you more energy and because of that wavelength. So what did we learn today? We learned that about the differences in color of light is related to the wavelength and frequency. Frequency is the amount of waves in a given section. So this has a relatively short wavelength compared to this wave here. Now, this has a big frequency, or a big frequency, we'll call F, and this has a low wavelength. Which one has a big frequency and a low wavelength? Well, the answer is this one right here, because the waves are very close together. So if you have a low frequency, that means there's not a lot of waves. There's only 4 waves on this line. And you actually have a very long wavelength. Okay? That's really ugly writing there, but you get the idea. Okay? So wavelength and frequency relate to energy of the wave, and we know that light is composed of different colors. These are all important things that we need to know. Light can carry energy, and it's a wave. Thanks very much.